All right, here we go. So I'm asking here for you to plot Z, W, and W times Z. However you did it, if you plotted Z, plotted W, and then did Z times W and plotted that, that's fine. I'm going to look for Z times W first, so I have everything I need, and then I'll just convert that into my coordinates. So when I do Z times W, or I guess in this case, W times Z, quick question. Will I get the same answer if I do Z times W or W times Z? Yes. Why do we know this? Is what? Commutative. Very good. They have the commutative property. Order doesn't matter for multiplication. So if you wrote Z times W calculator, or you did the W times Z like the directions say, you actually get the same results. So don't ever stress about what order to do it. But this ends up then being 1 plus 2i times 3 plus I. And when you have two binomials being multiplied together, what do? Distribute. So all of this should be a good little review. So 1 times 3 is 1 times I. 1 times I. Just I, or 1i. I don't count off for that. 2i times 3, 6i. 2i times I. And what does 2i squared going to turn into? -2. This I squared becomes a negative, so this is a -2. So when I combine like terms, what's 3 minus 2? 1. And what's I plus 6i? Very good. All right, so if we write these all out as coordinates, what is Z as a coordinate? So I'm going to come over here. I'm going to go to, these are going by 2s. So 3 is about right here. 1's about right there. We're going to draw them as a vector. And so this will be what I call Z. W will be what? 1, 2. So I'll graph 1, 2, which is roughly like that. So there we go right there. And then this is W. And then going back to my red pen. What is the W times Z's coordinate? Yeah, so that is WZ. Any questions on how to do this? If you haven't already, go ahead and take this time to do B and C. Make sure that you can graph vectors correctly and you can distribute correctly. We'll go over it to verify that you got the correct answers, and then I'll wrap it up on D. I have one more example to show you, and that pretty much is today. All right. It's good. So the math, as I said, it's not going to change. We're just going to notice something now and then go from there. If you haven't already, you're doing B and C. And then I'll go over it to verify you got the correct answer, and then we'll wrap it up on that D. Well, I got one more example after that, which is probably a little bit harder than what we're doing now, but still something we shouldn't be too scared of. And then, yeah, then I'll be done. Do what? Yes. Yeah, like just standing for so long. Like if I'm walking and moving, my back don't hurt. If I'm just standing, can't do it. Anyone need help or assistance on graphing or foiling?
The I squared, right? And it turned into a negative, but there's not a number there. So
But there is. There's like a -1 there.
Okay.
So that negative I squared would then become what?
Positive.
There you go. I'm going to do D together. I actually just going to skip all that, but I'm glad you did it though. I was going to start on 2, or I think is it 2? No, I was going to skip to 3. All right, we already done with B and C. Looks like majority of y'all have stopped writing. Oh, I was like, did not have time to do it. All right. So look at B real quick to make sure we got it all right. So again, WZ or ZW process is not going to matter. -1 times 1. -1 times 2i. 4i times 1. 4i times 2i. And the 8i squared will turn into a, so -1 minus 8 is -9. And the -2 plus 4 is +2. Very good. All right, so let's make sure we got all the correct coordinates. What's the coordinate for Z? 1, 2. What is the coordinate for W? I also want to make sure you are graphing coordinates correctly. I think when I was grading, I think it was less than 9. Some of y'all are graphing incorrectly. So make sure you know it's x-axis for a real axis, then the imaginary axis. I think I wrote notes when I saw the mistakes. What is the coordinate for WZ? Everyone still good? Everyone got the correct answers. All right, let's look at C then to verify that we're still 100% good. And then we'll wrap that up with D. All right, WZ. -2 times -1. +2. -2 times I. -2i. -I times -1. +I. -I times +I. -I squared. And this will become what? +1. This is a -1. So this whole thing becomes a +1. So 2 plus 1, 3. -2 plus, or -2i plus I. -I. Very good. What's Z labeled as? -1. Very good. You are correct. W. And then my Z. Or WZ, sorry. All right, so part D says, for each A, B, and C, we drew the line segments connecting each one of them. Determine a relationship between the arguments. What does arguments mean? Not the distance. The theta, the distance as in radians or degrees, if that's what you're trying to think about distance. So that's the degree of rotation. All right, so what can you notice? And we'll look at this one here. What can you tell me about the argument of Z, the argument of W, with the argument of W times Z? What can you say about a relationship there? Huh? It increases. I like it. What else do you notice? What do you mean by that? Ooh, not multiply, but add it. Very good. If you can notice, it's kind of hard to visually see, but this red is part of the green. And let's see if I'm able to move things. Can. If I was to move this yellow, that's weird. as you can kind of roughly see, is that yellow there would roughly be that equivalent that would finish off the green. Now, that's a good theory. Let's make sure we're correct with that theory. So to review real quick, to make sure we're good with D, how would I find out what the argument of Z is? Nope. We did this yesterday, guys. Who? Good, the inverse tan. So I'm going to put theta with a Z here, just so I know which one it is. And it's going to be tan inverse. Oh, someone brought up a great question. Does tan inverse always work? The answer is yes. So then the follow-up question from yesterday's last sixth period was, well, then do I even need to use and find the unit vector? Well, technically on an SAT question, no, as long as you're getting the right answer, they don't care how you're doing it. So you could technically use the tan inverse to figure out what the degree is. The issue comes if it wants the degree as a radian. So if it like a specific like pi halves, pi fourths, pi sixths, pi thirds situation. So if you were to do tan inverse, and let's say you get 135 degrees as your answer by using the tan inverse rather than the unit vector, but it wants it in radians, just convert it to 3 pi fourths. Like you already have the results there. So then that wouldn't be on there. So then you would have to just switch your calculator to radians. Because the issue is if it's not one of those whole ones, it won't come out into a nice clean pi radians type of form. You would have to switch your mode on your calculator to radians and then just have a decimal as your answer. Well, I didn't even think about it. I just automatically just went to unit vector because I was wanting to utilize that. But technically, we could use tan inverse every single time. All right, so I just wanted to show you all that because it came up to yesterday, last period, and I was like, well, you know what? You're right. So what's my B and Z situation? 1 over negative 1. All right, so in our handy dandy calculators here, let's go find one. This is on, yeah, we're doing the work on D. I just want to keep it, well, you can put it on C too if you want. I just want to keep the work so we can see it. And I want to keep this in degrees so I can easily see this. So what mode should my calculator be in? We're not. We're going to do number 3 though. Right? So do make sure this right here says DEG, and remember to change it. All you gotta do is just click it and you can switch between modes. It's not like you have to go into settings or anything like that. Recall that the tan or the trig option is right next to the 7. And then we're just gonna choose tan inverse. And then I like to, yes, sir. Yes, sir. I like to do control divide to make it that fraction, which I believe ours was 1 over negative 1. And we get negative 45 degrees. So our question that we have to come over here with is I get negative 45 degrees. What quadrant is negative 1 comma 1 in? It's in the second quadrant. So what do I have to add to negative 45 to get the correct degree? 180. So what's 180 plus negative 45? 135. There you go. So if you were asked to find the radians of this, you could easily just look over there and say it's 3 pi fourths. Right? Or memorize your unit circle when you're taking the SAT test. All right, so that's Z. So let's look for W because we're trying to verify that our theory is correct. So if I do tan inverse of W, what's that fraction going to look like?
I was curious if you know what I got on
I did. I already posted it.
my.
It'd be negative 1 over negative 2. Yes. If you wanted to simplify that and make it 1/2, you wouldn't be wrong either. All right. So let's do that. Let's go back to our handy dandy calculator. Damn. So yeah, trig, tan inverse, control, divide. I done forgot it. What was it? Negative 1 over negative 2. I have it written down right there. All right, so we get this 26 point whatever. What quadrant though is -1, -2 in? 3. What do I have to do with quadrant 3? I have to add 180 because it's only going to give me this portion. I want the entire portion. So I'm going to take that answer and I'm going to add 180 to it. So that is my degree of rotation. It is 206 point blah, blah, blah. All right. Again, that was 206.56. All right. All right. So if this theory works out, that means when I do this work here, tan inverse, what is the WZ's tan inverse one going to be? Perfect. So let's see what the calculator gives us before we test out our theory. There we go. All right. What was the -1 over 3? All right, here we go. All right, what quadrant is -1, 3 in? The fourth quadrant. So I need to do what with the fourth quadrant? Add 360 to it. Very good. So I'm gonna go plus 360. Yep. No, it's 3, -1. Remember that's B over A. So 3, -1 falls in the third quadrant. So add 360 and there I go. So I can kind of see, I'll write this result down. What was the number? 3, 4, 1, 5, 6. If our theory is correct, I should be able just to add these two and get my conclusion. So let's do that real quick in the calculator to verify so we don't make any simple mistakes. Let's take, well, guess what was it? It was this plus 135, right? Do I get the exact same decimal? Yes. So our theory of the argument of W plus the argument of, you bathroom? Oh, yes. 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 Correct, because it gives you the clockwise -1 here. Also add 180, because what it does here, it gives you the counterclockwise, but it only gives you this degree. I need the entire degree, so it only gave us partial.
Is it also 180?
Quadrant 4 would be 360, because what it did, it gave you the clockwise negative version. So for me to find the entire thing, I need to go backtrack 360 degrees. Okay. Any questions there? So knowing that fact, that is our conclusion in D, is if I want to know what the argument of WZ is, I could just figure out the argument of W, or if I was given the argument of W and the argument of Z, I could just add those up and already be done. So coming back over here. So for part D there, what we just learned is that the argument of Z plus the argument, that's not how you spell argument, of W will just equal the argument of WZ. Questions? So we got to visually look at it. We thought about it. It looked right. We just algebraically did it, and it all worked out in our favor. I'm not going to do exercise 1 and 2, so you can go ahead and delete those, cross them out. I would like to go over exercise 3, and this will conclude my today's lecture. I do apologize for the noise out in the hallway. No exercise 1 and 2. You just don't do well with proofs. So I'm just going to go ahead and bypass that and go into more of the math calculations for you. And really and truly, you don't need to know proofs. They don't really ask proofs in SATs and ACT questions. They do in college, just depending if you're a STEMS major, you'll have to go through all that. All right, so here we go. So this one says if Z and W are the complex numbers with the specified arguments in the moduli, remember the moduli is the same thing as the modulus, the distance, the magnitude, the absolute values, all the things. Locate the point that represents the product WZ on the provided coordinate axis. So if I wanted to, I could easily identify exactly what my argument's going to be for W and Z. The alternative here is I need to figure out what the original complex number of W and Z is so that I'm able to calculate what WZ's point is. So this is kind of a review from lesson 13 when we went from polar form to coordinate form or rectangular form. So here, this represents what? What letter did we use? R. And my argument is my what? I wrote it up on the board too. Well, not radius, the theta, right? It's the degrees, the radians, right? So this is my theta. So what I can do is I can convert this in polar form and then turn that into rectangular form. It is the modulus. So we learned that the R is equal to the modulus. Could be. This is the modulus, which is the magnitude. Which is the distance. And we calculate two different distances. We calculate it as if you're going from the origins to square root of a squared plus b squared. And then in lesson 12, we calculate the distance of two different complex numbers using the distance formula of the difference of the x squared plus the difference of the y squared and the square root of that result. Right? But all of these things all mean the exact same thing. Right? So I can ask 5 different questions asking the exact same question. You just got to realize that it's the same question being asked. Right? So to work this out, remember that the polar form is written as, well, I guess this is W. This is going to be R parentheses cosine theta plus I sine theta. Do y'all remember this from lesson 12? Hope so. Hope so. We're going to plug in what we were given, the R and the theta. So this is now going to be 3 times cosine of pi fourths plus I sine of pi fourths. Right? It would told us what the argument was. Is theta. So in this case, I'm going to do some little math using my unit circle. Recall on trying to figure out your answers. If it asks for the cosine and the sine of a certain degree, I can come over here to pi fourths, which is located right here. My x value represents the cosine. My y value represents the sine. So I can now replace cosine and sine of pi fourths with these two fractions here. So cosine pi fourths ended up being the square root of 2 over 2 plus I square root of 2 over 2. What would I then do with that 3? Multiply everything. Now remember, when multiplying fractions, you're really just multiplying the numerators. The denominator will remain the same. So this becomes what? And this becomes what? With an I, right? You've now found out what W is, right? So now we got to do the same thing to find out what I is. So same math. This time, this is the R and this is the theta. So this would then be 2/3 times cosine of negative pi halves plus I sine of negative pi halves. right? Again, just plugging in to the polar form equation. Here's the thing that you might not know, but we've said it enough times where you might be thinking about it. Since my radian is a negative, what direction on my unit circle will I go? Clockwise. We've been going counterclockwise with positives. Negatives indicates clockwise. So if I went negative pi halves, what's originally pi halves? So what would negative pi halves be? 270. So there is the coordinates I am looking for. So there is my cosine and there is my sine. Absolutely. Yeah. Oh, you're talking about for not in this situation, not when talking about polar form. They're going to have the same theta. Okay. So you'll go to the same spot and take that coordinate every time. Later on, when we learn more about trig, probably next semester, we can totally have different values for trig. For like, I could do sine of 90 plus cosine of 30 or something like that. And then you would add that up. All right. So this was 0 plus I times -1. So this is kind of nice. We got whole numbers. What's 2/3 times 0? 0. What's 2/3 times -I? -2/3 I. Right. We've now calculated our Z. So the question here was locate the point that represents the product of WZ. Well, now that we have our Z and W, we can multiply the two and we can calculate our product. So here we go. So we have 3 square roots of 2 over 2 plus 3 square roots of 2 over 2I times, do I really need the 0? No. If you want to write it, that's fine. But this is really just going to be -2/3 I. Typically, you would FOIL, but our life's a little bit easier because all I got to do is just distribute. All right. So let's see how good our fractions are. How would I multiply these two fractions? What do I do? Multiply straight across. So what's 3 square root of 2 times -2? -6 square roots of 2. What's 2 times 3? 6. There was an I, so that becomes an I there. Here, when we just pulled the coordinate at -pi halves, it was 0, -1. Well, okay, so it depends on where you're looking. We have a -pi halves, so pi halves would have been this direction, but -pi halves told us to go in the same amount, but in the clockwise direction. So -pi halves is actually the same thing as 3 pi halves or 270 or this coordinate here. So it's actually going to be 0, -1. Had that been a positive 1/2 or pi halves, then yes, you could say 0, 1. What was your result? But because it was negative, it went clockwise 90 degrees. Right? All right, so now that we have this, we can do the next one. What's 3 square root of 2 times -2? Good. 2 times 3? 6. I times I. I squared. All right. What's going to happen to that I squared? All right. Which basically is going to make that positive. Right? If you need to write it out, by all means, write it out. What else can you seek and cancel? The 6's. I can take this 6 out and I can take this 6 out. But then I'm going to write it in the correct form. What should be the correct form of my WZ here? Very good. If you put the I right here, that's completely fine as well. Go ahead. This one, it came from over here. So it was originally negative and the I squared made it a positive. Good question though. All right, so again, the question said provide the coordinate, provide the where it represents over here. Obviously, we don't have square roots on here, so we do need to convert them a little bit into decimals. What is the square root of 2 as a decimal? It is something. Thank you. So converting these into decimals just so I can figure out where it falls on the graph here. Where would this graph? How would I get there? Describe it to me in the directions. From the origin, how would I graph 1.41 minus 1.41i? On the x-axis, okay. We'll roughly say it's about here. And then what? Very good. So we'll say about right here. So there is your WZ. I want you to do B and C. And that will conclude today. So you have to turn it into polar form, convert that into rectangular form, multiply your two rectangular forms together, and get your WZ. Are you cold? I got you. I'll turn it off.